Hello everyone, this is Prashanth. This is the class for IoT physical device and endpoints. So just we have to what are the IoT physical devices and endpoints here. Along with that, just we have different modules like Arduino, Raspberry Pi, along with Python programming. So by using Python programming, just we can implement some interface devices on Arduino device and Raspberry Pi devices. So these are some course objectives. Here understand the fundamental concept of IoT and its components, learn about the Raspberry Pi and Arduino and Raspberry Pi as it core IoT device platforms. Very important. Next, master the installation and setup of Arduino and Raspberry Pi development environments, that is okay, and acquire efficiency in using serial SPI and I2C communication protocols. Develop Python programming skills for Raspberry Pi to interact with the external devices. So these are some course objectives I am going to explain in course. Next, implement a project involving input-output operations like sensor interacting and actuator control, like that. The last one, gain practical experience in building IoT prototypes and applications. In terms of IoT device and endpoints, just we have some course outcomes also. Before that, course objectives, it is outcomes, and successful of the course is here. Explain the architecture and functionality of Arduino and Raspberry Pi boards. So just we have only Arduino and Raspberry Pi boards only. Along with this, just we use some external devices to implement IoT devices. So select appropriate hardware components and interfaces for IoT projects. Interface is nothing but by using communication protocols. Write Python programs to control general packet input output pins, read sensors, data, and device actuators, like that. And implement communication protocols for data transfer between the devices, that is okay. And troubleshoot hardware and software issues on IoT system, design and build communication protocols, like that. So these are some course outcomes I will explain. So here these are the IoT introduction to IoT and hardware platforms. Here these are the objectives and outcomes we already know. Objectives include define IoT and its key components. What are the key components available in IoT? Identify different types of IoT device and applications. For every device having different applications, like that we have to discuss. And understand the role of hardware in IoT system, like that. And introduce Arduino and Raspberry Pi platforms. That is very essential things of IoT platforms. Arduino and Raspberry Pi. Very important. Arduino and Raspberry Pi. Outcomes: students should be able to explain IoT concept of IoT. They are able to differentiate between the various IoT devices, like different sensors, different sensors gathering different data, like that. Students will be able to identify the key features of Arduino and Raspberry Pi. Next, overall, to set up the Arduino and Raspberry Pi setup. So these are the objectives. Install Arduino IDE and necessary libraries. IDE, environment development integrated. IDE stands for integrated development environment for necessary libraries in order to write the programs. And set up Raspberry Pi operating system and development environment, that is okay. Configure basic input-output operations on both platforms. Compulsory, we have to give some information. Based on that, we have to get some output also. Outcomes: students will be able to install and configure Arduino and Raspberry Pi software. It will be able to perform basic programming tasks on both platforms. That is essential things. This is the topic 2. Next, topic 3, communication interfaces, very important. We know In previous slides also, just I will elaborate interfaces, communication interfaces like serial, SPI and I2C. SPI is nothing but serial programming interface. I2C, inter-integrated circuit, objectives and outcome. It explains the principles of serial SPI I2C communication, understand the advantage and disadvantage each protocol. Like that, some objectives include based on these three, and outcomes. What are the students should be able to appropriate communication protocol for a given application. So which type of application they are using, based on that which type of protocol they are used to develop that particular application. So that is the very essential thing for students. And students will be able to implement communication between devices using serial. Serial is nothing but UART, universal asynchronous receiver and transmitter communication protocol. Serial in the programming and inter IAC, integrated circuit. That is okay. Next, the fourth topic involve Python programming with Raspberry Pi. Compulsory, we have to write the programming code with to implement the Raspberry Pi. Introduce Python basics for Raspberry Pi. We already completed the lectures on Python, and learn to interact with general purpose input output pins for input and output operation. And Python libraries like data types, data variables, file handling techniques, list tuples, like that. We have to discuss some about the library, and Python scripts for data acquisition and processing. Based on that, the students will be able to write Python programs on GP, general input output pins, and students should be able to interface various sensors, actuators with Raspberry Pi. And able to process, analyze sensor data using Python. So these are the fourth topic on the IoT device and endpoints. Next one, the last fifth point here, IoT projects and applications. So based on the entire theory which is learned earlier, based on that, just you can apply on the real-time devices. So that is the project I did, should just to develop the IoT project based on that applications. So that is very initial thing. Objectives, design and implement small scale IoT projects, apply learned concept to real world application solving, and explore advanced topics like cloud integration and data analytics. Like that, we have some objectives based on that IoT projects. And outcomes, the student should be able to develop functional IoT prototypes, should be able to troubleshoot and optimize IoT systems. It will be able to demonstrate critical thinking and problem solving skills in IoT context. Just we reach Bloom taxonomy level 6, that is critical thinking, just we reach based on that real time projects. So that is the based on that IoT projects and applications. Next one, what are the focus on the hardware part. We focus on the hardware part, that is Arduino and Raspberry Pi comparison. Just ATM card size mini computers. Both are one is just belongs to microcontroller part, microcontroller family. One is belongs to microprocessor family. Arduino and Raspberry Pi, very important. Just it act as a mini computer. With the help of these two, we can develop huge applications or huge amount of, just we can use huge amount of applications also. Sensors and actuator interfacing, just we have some information to analyze from the sensors. And power management, efficient power usage for battery powered IoT devices, and IoT shield and add-on boards, overview of popular shields and their applications. So these are the focusing on hardware part. Next to software part. Software is nothing but IoT Python for IoT. We know, just you can by using different IDLEs, Anaconda, To write the programs, we have different IDLEs. Ideally, Anaconda, PyCharm, Google Colab, like that. We have different IDLEs. Data acquisition and processing for real-time data handling, storage and visualization process. Cloud integration for connecting IoT device to platforms like AWS, Amazon Web Services, Azure, Google Cloud, like that. The last, we need IoT protocols like MQTT, COAP, other communication protocols for IoT, IEEE 3.4.0, like that. Every based on the requirement, just we have some communication protocols for IoT. The next one, project-based learning. Here we have different applications: home automation, environmental monitoring, IoT for agriculture, IoT for healthcare. Nothing but IoT, medical, agriculture, health, environmental, and home automation. These are the 4 domains, very, very important. 4 domains of developing IoT applications. Home automation, building a home smart home system with multiple sensors and actuators. For security, for fans, for ACs, for TVs, whatever the electronic appliances are available in home, that can be connected to the internet, just to make it make smart world, IoT smart world, like that. In project based learning, home automation also one of the domain. And environmental monitoring, to monitor the environmental condition like humidity, pressure, temperature, whatever the environmental parameters that can be calculated by different sensors to implement any project based on environmental monitoring. And IoT for agriculture, now to develop the drip irrigation system, like that. We have different methods for IoT for agriculture. Next, medical, patient monitoring system, health monitoring system, remote patient monitoring system, like that. We have different projects based on the IoT. That's why these are the 4 main domains of project-based learning for IoT. Next one, what is an IoT device? What are the key components of IoT device? It is very essential. IoT device is a physical object that can interact with, share the data. It typically contains sensors, actuators, and network connection. Some common example for IoT device include smart thermostat, wearables, home assistants, and industrial sensors. Some key components of IoT device: sensors, actuators, network connectivity, and processing unit. Gather the data, save the data, analyze the data, process the data. So these are the some key points regarding IoT devices. Next, types of IoT device based on function: sensors, actuators, and wearables. Sensor to collect the information, some temperature sensor, humidity sensor, light, motion, air quality, whatever. For every function having one sensor. Actuator, this device control physical systems like motors, lights, and valves. Wearables, wearable device, watch, smart watch, smart weighting machine, like that. We have different wearables based on the function. Next to home automation device, industrial IoT device and automation IoT device. In home automation device, smart thermostat, smart lights, smart speakers, security system, like that. Industrial IoT, sensors, actuators used in manufacturing, logistics, and energy environment. IoT, automotive IoT device, connected cars with features like remote diagnostics, infotainment, and automotive driving capabilities. Like depends on the function, we have different IoT devices. Next, based on industry, healthcare, industry, wearable medical devices, remote patient monitoring system, smart hospitals, like that. And agriculture, smart facing equipment, soil sensors, drone based manual. In retail, inventory management system, smart slaves, and customer behavior analytics. Logistics, smart containers, vehicle tracking, and small supply chain optimization. In energy, smart grids, energy management system, and renewable energy monitoring system. Based on size, microcontroller, single board computers, microcontroller, ESP8286 is very important microcontroller to explain to build IoT device. Single board computers like Arduino, Raspberry Pi. Just now we discussed about it is ATM card sized mini computer. It is used for a lot of applications, to develop a lot of applications. And embedded system, it is the combination of hardware and software with mechanism. That is one of the based on the size. Next one, block diagram of IoT device. Here we have different devices like connectivity by using USB and RJ245 Ethernet, processor, CPU, graphics CPU, audio video by using HDMI cable, 3.5 mm audio, RAC video, like that. In terms of interfaces, NAND, NOR gate, DDR1, DDR2, DDR3. In terms of storage interfaces, SDRAM, MMC, MMC, SDIO input output there. Interfaces by using UART, SPI, I2C, and CAM. So these are the basic block diagram of IoT device. It having different specifications based on the application we may use based on the application. Next one, IoT physical device and endpoints. The understanding of basics here, we already know IoT physical device are the tangible objects equipped with sensors, actuators, and network connectivity that enables them to interact with the digital world. Essentially, they bridge the gap between the physically and digital realms. So this is the main concept of IoT physical device. Endpoints is an IoT context, refers to the termination points of communication channel. This can be IoT devices themselves or other system. To interact with them, for instance, a cloud platform where the data is stored and processed can be considered an endpoints. So this is the IoT physical device and endpoints interaction points. Some key components: sensors, actuators. We already know sensors, actuators, microcontroller or processor, connectivity, and power source. Just these are the key components. Gathering the data, authentication, connection, process, gather the data, processing the data, analyzing data, develop the application. Like that, just we have to maintain for every application here, from sensor to power source, how much power it need, whether the power consumption is less or power consumption is more, what are the problems to get high, to get low, like that. Next, example of IoT physical devices, we know wearable devices, smartwatches, fitness trackers, health monitoring, like that. Home automation, thermostators, lights, speakers, security systems. Industrial IoT, sensors for monitoring equipment, health protection. Whether a large equipment are available in industry, whether just in order to monitor that that mission life cycle, whether how many years, how many days it will working efficiently, like that. The life cycle of that particular mission, it can be calculated by the device, IoT device. Next, automotive, connected cars with features like diagnostic infotainment, autonomous driving. The last one, agriculture, soil mastering sensors, drone based cropping monitoring system, automated irrigation system, like that. Next, challenges and considerations here. In terms of challenges, we have to maintain some security protocols, power consumption, data privacy, interoperability. Interoperability is nothing but, for example, in this room, the some other company, MI remote are available. For that MI, with this MI remote, just we can operate other company AC. We can other company AC we can operate with MI remote. So the companies are two different. That is the possible with only interoperability communication. Very, very important interoperability option. It is very, very important in our home also. So my TV, the MI TV, but the remote, the mobile is Samsung. With Samsung mobile, just I can operate with MI TV. That is possible only with the interoperability option. Scalability and popular platform Arduino, Raspberry Pi and ESP8286, 8266 platforms. These are the some challenges consideration to install or to develop the IoT application. Next, would you like to develop deeper into a specific aspect of physical devices? There is some hardware components, communication protocols, IoT platform and development tools, real world IoT application challenges and solutions in IoT development. So these are the topics I'm going to explain here. Remaining continue with the next class. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.